We're the SAE Blizzard Baja Enterprise, and we're a student-organized, faculty-advised off-road racing team. We design and build an off-road single-seat car, and then we race regionally and nationally. We currently have 27 members on our team and host a yearly Winter Baja race.
I'm Alex Sherry.
And I'm Kyle Harris.
We're part of the senior Steer Senior Design team. So our overall goals for this project were to build a 4x4 capable steering system, as our old one wasn't quite up to the standards that we need to reach next year. Decrease the steering ratio and implement power steering. So we had to adjust the layout of our steering system a little bit. We had to move it in front of our new differential, give the space for the differential, and move the Ackerman arms to the front of our knuckles.
So the design, validation, and power steering integration, we needed to add clearance for the power steering unit above the diff. So we use a double pinion rack and pinion system. And then the power steering unit's also removable. So you can remove it and replace it with manual steering only if something breaks mid-race. And then the code references torque and steering angle through a torque and angle position sensor in the power steering unit to determine how much assist is given through the motor. And we did FEA on all major components of our rack and pinion, like the case, the rack gears, shafts, clevis ends.
This is the 4-wheel drive senior design. My name's Leaf Kett.
I'm Nishant Peruri.
And I'm Jack.
So for 4-wheel drive implementation, the requirements were that front and rear wheels must spin. We wanted to turn the 4-wheel drive on and off with buttons in the cockpit, keep the added weight under 12 pounds, and implement around the new diff and current engine and gearbox. Why we wanted to do this year, the team gets extra points at competition if we implement 4-wheel drive. Next summer, 4-wheel drive is required for the competition. And we believe that with 2-wheel drive, it could be faster top end because of less drivetrain losses.
After much deliberation, we decided to go with a chain drive for our 4-wheel drive implementation. The routing was on the previous slide, but the way that we were achieving this is through a set of pulleys and plates that will run off of the main gearbox. To implement the 2-wheel drive and 4-wheel drive turning on and off, we took inspiration from the synchro mesh in a manual transmission gearbox. The plan is to use the synchro teeth that are currently made and then run a solenoid that would be electronically actuated from the cockpit off of a mechanical arm to move the selector fork, just like in a regular gearbox, to engage 4-wheel drive and turn it off on the fly.
All right, so for the rear axle, where the power is split halfway to, there are 3 major components, which were brake mount, axle, and the axle mount itself. And the design criteria are mentioned in the slides for a 600-pound vehicle coming from a 30 miles per hour to 0 in 11 feet, and 60-40 brake distribution, and assume that there's no friction and all load is on the mount. And the axle and axle mounts are designed to withstand more than 500 foot-pounds or 6,000 inch-pounds of force. And axle went through a few design iterations due to the high torque application. So validation and integration, all the FEA results yielded to a principal stress well below the yield strength of the material. Design was optimized for high torque, durability, serviceability, and manufacturability. And the assembly is shown below. And Hubs, I will be presenting, Nishant Piruri will be presenting for Hubs Senior Design for Joey Golinsky and Zach Conrad. So the rear hub has been redesigned. The project objective is to reduce the diameter, minimize the mass, ability to manufacture in-house. Selected a smaller bolt pattern, decrease the spline tool length or spline engagement length. And the pictures relating are shown in this slide.
So for design validation next steps, design validation, they validated the design using FEA analysis for a stronger and lighter hub, and 3D printed to validate fitment. For the next steps, we want to investigate the lightweighting of the rear wheels. As you can see to the left, you have the FEA and the 3D print and potential lightweighting solution.
Hello, my name is Chase Ritleski, and I'll be representing the Ergonomics Senior Design Team. Our project objective consists of designing and manufacturing more comfortable components for our drivers. And at the same time, we'd like to reduce the weight from our previous components. We did this by utilizing carbon fiber for its strength and lightweight properties. Our steering wheel design originated from a CAD model as shown in the first figure on the left. As one can see in the middle figure, we relied on composite manufacturing to produce our steering wheel, using 20 layers of 45-degree biaxial carbon fiber and 4000 series resin, which is optimal for resin infusion processes. After removing the excess material in the post-processing phase, the final product is now ready for competition this summer. Another aspect of our project is designing a seat. Similarly, we use composite manufacturing, constructing the mold in the first figure to meet the expectations and desires of our drivers. The pattern we chose to lay the carbon fiber in resulted in reduced creases, leading to minimized voids in the finished product. Our process consisted of using 8 layers of 90-degree biaxial carbon fiber with 2000 series resin, which is more viscous and will yield higher strengths. Lastly, the image on the far right is the current state of our product, still requiring further post-processing that we will complete in the coming week. As for our design validation, the steering wheel is currently lighter than our previous design. The seat is also lighter and more accommodating to our driver. The seat can be placed closer to the firewall, allowing for more legroom in the cockpit.
Thank you to all of our sponsors and advisor Kevin Johnson and Stephen Ma, and the MMET machine shop staff.